Today I'm going to go through the lesson 10 of the Elegoo starter kit for the ultrasonic sensor module. And here is basically their format for all of their lessons so far. There is an overview of how it works. The module HC-SR04 looks like a pretty common module that you can get from a lot of different sources. There's some really good information online. I tried to find actual schematics of it, and I don't think I found anything that actually works. Let me move this over. So I found this, which I think is a pretty good representation of what might actually be there. There's going to be a microcontroller. This is a Max 232, and it drives a speaker module. I'll call it a speaker module. And then it looks like the exact same kind of module. It receives the echo and goes into a quad op amp and has some circuitry built around that. And so I wasn't sure, you look at these things and you go, do those actually work? And so I redrew it, and I don't know that the way they've shown it would actually work. So there's, this is their microcontroller, the Max 232, driving the ultrasonic driver, and ports 60 and 61 receiving something from the op amp circuit. It drives something into the op amp circuit, which feeds back into this, which I'm not sure what to call it, but it's another stage. The speaker drives into this, or the receiver from the speaker output drives into this, which comes basically to the output of this. I don't really see how this can provide a signal back to the microcontroller. So maybe I just don't understand it, but it doesn't look to me like it actually works. But it has the components that seem to make sense. So maybe it works, and I just don't understand it. But there's that. And then back to the tutorial. Like they always do, they tell you the components you're going to need. They give a little rundown of how it works. You get 10 microsecond pulses going out, and at 8 of them at 40 kilohertz, and the time it takes for that to return is how the distance is measured. Velocity. Yeah, you can look at this formula. Okay, 140 meters per second. Yeah, that makes sense, I think. And so they give you a little timing diagram. The trigger pulse goes out, the sonic burst, 8 cycles, leaves the module, and then a pulse is returned with a time high proportional to how far away the object is. You got the connection diagram. You power it, trigger it, you connect the echo, and you connect ground. Then you have a wiring diagram, and the little rundown, make sure you upload the libraries, otherwise it won't work. And then a photograph of how they connected it up. So I will close that, and you'll see that I did it a little differently because I wanted to put stuff on an oscilloscope. I got this module project board that I put it on and connected to the Arduino to the project board, and then I brought out some leads so I could put it on a scope. There's 4 of them: the trigger, the echo pulse, the driving waveform, and then the receiving waveform. 4-channel scope would have been nice for something like this, but what I did was over on the scope, I put these cursors where the pulses came out of the module, and so I have the echo on the scope, the trigger on the scope, and I have the echo on the scope. The pulses will be right in here, and then the received pulses will be detected right here. So let me show you how those work. So there you see the trigger and the echo, and then if I move this to the transmitter element, you'll see 8 pulses come out. And let me put this to single, and when it shouldn't have done it. Should trigger. See, up here's the trigger. There you go. When it turns green, it triggered, and since it's on single, it just acquires once and sits there. And now if I zoom in on that, there you'll see it has the 8 pulses. 1, 2, 3, 4, 5, 6, 7, 8 pulses, and the cursors are I don't see the measurement for that. Here we go. The cursors are 213 microseconds apart. So you divide that by 8. Or here you go, kilohertz, 4.69 kilohertz times 8, 40 kilohertz, give or take. So we'll go back to the normal mode, so it will keep acquiring. And of course, let me show you real quick. If I went to auto mode, when it acquires, you'll see it and it'll disappear right away. So that's why it's on normal mode. So it'll acquire and it'll stay on the screen, like there. Now, let me now, so now you know where the echo pulse starts. Let me go back to the echo pulse. Okay, now I have this target that it reflects off of. So if I move that away, you'll see the distance increased from 4 or 5 centimeters to 16 centimeters, and the length of the pulse increased. Okay, and if I were to measure that, I don't know, I'm just guessing. I don't know how accurate that actually is. I actually don't care. I'm really just wanting to see how this thing functions more than anything, rather than how accurate it is. So now if I look at the received echoes, on the yellow wire. It's pretty small. You can so I have to change the scale on the scope, and we'll go 100 millivolts. So you can kind of see right there, it detects it like right in there. And that's really all there is to it. The echo pulse is from the end of the transmitted 40 kilohertz signal to when it receives something coming back. And if I move that, so does the echo pulse or pulse train. Okay, that's it. Pretty straightforward. Took me a while to get that all figured out and set up so I could show something. So there you go. We'll do lesson 11 sometime maybe next week. All right.